disgusting.
The normal one and the red one.
I like Alani News.
The normal one is so bad.
Shh. Let's start.
Waiting on you, sir.
Do you like those ones?
Yeah.
Okay. Yeah.
The
Kira.
best is the dragon.
Get ready.
Can
It's
we
coming.
see who's on
I
the
am
arrow?
ready.
It's coming.
I am ready. Wait, what's coming?
Oh, that's your only chance. All right, last time we were talking about finding the domain and range of a rational function. There we go. So one meaning of rational is sane or reasonable. This is not what we're talking about. So what is rational as relates to a function, Sydney?
Sorry?
What does rational
Yes.
mean for a function? What's a rational number?
Anything above 0?
No,
Anything that's not
that's a
decimal?
non-negative number. That's a positive number.
Anything that's not decimal?
That is a whole number.
Anything
Or
that's
an
not a square
integer.
root?
That is a real number.
Anything that's not a square root?
So let's look at the word rational.
Oh my god. Can you tell me the
Oh,
origin
it can't
please?
have it in like the denominator or something.
Nope.
Can you use it in a sentence?
Hey, can
What's
you use
a-
it in a sentence, please?
What's the meaning of a rational number? What is a ratio?
Oh,
On
something
comparison.
proportion, like
A proportion?
Proportion.
Like 2/3 or the ratio 2 to 3.
Yes,
I
So a rational number is anything that can be expressed with integers in the numerator and the denominator. So is square root of 2 a rational
No.
number?
I mean, probably.
Is
Yeah, it is.
is e a rational number?
No.
Is pi a rational number?
Wait, what was the definition?
Why isn't square root 2 a rational
What was the
number?
definition?
Because it cannot be expressed with two integers in the numerator or denominator.
Wait, a rational number is anything that
A rational number can be expressed as integers in the numerator and the denominator. Square root of 2 is irrational, e is irrational, pi is irrational,
Square root of 2 is not rational.
square root of 2 is irrational.
Why?
Because it can't be expressed as a ratio of two numbers.
Oh, okay.
Yeah.
What about pi? Pi's are rational, right?
Pi is irrational, e is irrational.
They're crazy, man.
So what's a rational function?
Pi over 2.
That's not a function.
You just said an irrational one.
What's the meaning of a rational
F.
function?
F of 3 over pi.
It's a function that you could describe with two integers and a fraction.
Yeah. So that's a little bit different than the definition of a rational number, because we're not requiring that x be an integer, but the function itself can be expressed as a numerator and a denominator. Numerator and denominator. All right. So last time we were making a table to find what happens as we approach 0 from the left. Let's see what happens when we approach 0 from the right. What do I mean by approaching 0 from the right? What do I mean by approaching 0 from the left?
You come up to it on the left.
The left meaning what?
The left side.
From the negative side. So let's do it from the positive side. I'm gonna write my table like this. I'm gonna, instead of starting with -1 over here, I'm gonna start with 1 over here. Do 0.5, 0.1, 0.0. 1, 0.001, 0.0001, 0.00001, 0.00001, and approaching. These are getting smaller, right? So I'm going to be approaching 0 from the positive side or from the right. So who wants to go first? The first one's easiest?
0.
No, so the first one is here.
Yesterday.
What is f of x when x equals 1? We did this one? We didn't do this part.
No, we did a different one, I think.
We did this one at approaching 0 from the left. That's where we left off. Okay, Amelia. What is f of x when x equals 1? Remember, f of x equals 1 over x.
1.
Charlotte.
It's the thing you said yesterday, the copy dot, is it?
So yeah, so f of 0.5, that's 1 over 0.5. I can write that as 1 over 1 half.
I think it's an F of 1.
Copy dot flip.
So yeah, you got that one right. Really fun.
Oh, I did?
Yeah, the
One
one
half
half
over-
Charlotte, I'm asking Charlotte.
2.
Yeah,
Oh.
it's 2.
Isn't it just gonna
Sydney?
be the same as it was?
Carlo.
It would be 10.
Yeah.
Stop answering for people.
What? I didn't say anything.
Oh,
That
somebody
was
did.
me.
Kira.
Did I really sound like Carlo?
Yeah, your voice is very low.
That's more
Oh my
offensive
gosh,
for-
no, you're
It'd be
so
10.
negative voice.
It'd be 10.
You.
Annabelle.
You actually had very baby voice.
Annabelle.
100.
100. Kira. What is f of 0.001?
1,000.
Carlo.
10,000.
Warren.
100,000.
Million.
Million.
Can I-
Amelia.
Wait. What? For 0?
We're not approaching 0. We're not approaching 0.
Just more.
What's the math term for just more?
Infinity.
Oh, sorry.
Yeah. So if you notice, as we approached from the left, from the negative side, f of x approached negative infinity. As we approached from the right, f of x approached infinity. Yes?
Can I look at my email from Miss Allie really quick? It's important.
No.
Please, it's actually, it's like,
No.
please, it's actually important, please.
You can step outside. So what is the graph? What are these numbers telling us? What does the graph look like?
It goes up really fast. It's like really high, but it's like doesn't go. It doesn't.
So let's graph some points.
I think you should graph the origin, or 1 and 1. I mean, 0, 0.
1, 1, 1 and 1.
1.
I also have -1 and -1 too, right? Up here.
It's negative. It's negative.
Yeah.
0.
It's like very, it's a very steep, well, it's gonna be an
What
inverse function.
what's the graph of where
This
is
so goof.
0.52 go?
It's like this.
The positive, like, half and
Half of it, and
Let's
it
see,
comes
it's
up to
right
2,
yeah,
and then 1/10 of it is at 10, so way up here.
yeah.
So it goes like this.
And then the negative version is gonna be the same, just steeper, like, just negative.
I've seen this
down.
before.
It's an inverse function. Yeah.
Right.
What?
So
Oh.
as x approaches 0, depending on which side it's coming from, f of x either approaches infinity or negative infinity. What does f of x approach as x approaches infinity?
0.
F of x approaches 0 as x approaches infinity. And what does f of x approach as x approaches negative infinity?
0.
Also 0. So does it ever reach 0?
No.
Does x ever reach infinity?
No.
Or negative infinity?
No.
What about as x is approaching 0? Does f of x ever reach infinity?
I don't. Yeah. Does it ever reach it?
Well, remember the function is 1 over x. So if x ever reached 0, then we would reach an undefined
How do you
function.
infinity?
Like this.
You
So-
can't do it.
So this is an image of why we say f of 0. What is the value of f of 0? So you're listening to her instead of listening to me. what is the value of f of 0?
Undefined.
It's undefined, and we can this actually shows a picture of why it's undefined, is because it's not infinity. We could just say, oh well, it's 1 over x, so 1 over x is, maybe that's infinity. That's not true, because if we approach x from the right, f of x goes to positive infinity. If we approach x from the left, f of x goes to negative infinity. So sort of at the same time, you would have to say f of 0 equals equals infinity and negative infinity at the same time. That's a contradiction. So we just say it's undefined. That's really why we say it's undefined. Also, both directions. So as we're approaching infinity here, I'm drawing this with a dotted line. This is an asymptote. This chapter is rational functions and asymptotes. So this dotted line that I'm drawing here is also an asymptote. So I've drawn a horizontal asymptote. Here's my horizontal asymptote. What's the equation of my horizontal asymptote?
Is it like the
It's this this dotted line right here.
like f of x approaches 0?
No, that is a line. So my horizontal asymptote is a line. What's the equation of that line?
Like 0?
That's not an equation.
Y equals 0.
Y equals 0. Y equals 0 is the horizontal line that runs through the origin. I also have a vertical asymptote. Here's my vertical asymptote. Warren, what is the equation of this dotted line? My vertical asymptote.
X equals 0.
X equals 0 is the equation of a vertical line that passes through the origin. All right, so let's get into some definitions so we can understand this a little bit better. Does my vertical asymptote have to run through the origin?
No.
So let's, not in this graph, but let's pretend I have a vertical asymptote that runs through this, that is here. It's located here. What's the equation of that line?
X equals -2.
That line is x equals -2. It has nothing to do with this function. I'm just showing you a different vertical asymptote because I'm going to say, in general,
Like it's just a constant.
it's a constant. So I'm going to say x equals a is a vertical asymptote of the graph of f when just like this chart here, when f of x approaches infinity or f of x approaches negative infinity as x approaches a from either left or right. That's a definition of a vertical asymptote. Let's try to figure out what the definition of a horizontal asymptote should say.
The line y
It should start with the line.
y equals
y equals, let's say b in this case, is a horizontal asymptote. Keep going.
Of the graph of f
Of the graph of f when
x approaches infinity
yeah,
or x approaches negative.
yes. I'm going to write f first. So I'm going to say f of x. What does f of x approach?
B.
B as
Left or right,
x approaches infinity
or negative.
or x approaches negative infinity. Okay, I'm going to leave that up for a second. I'm going to draw some examples. So I'm just going to draw a function here. This function is going to be f of x equals 2x over 1 and x, 2x plus 1 over x plus 1. Any guesses as to where it's going to have a vertical asymptote?
Negative 1? Oh, wait.
No? Yes?
Negative 1?
Yes? What's the equation of the vertical asymptote? What's the equation of that line?
X equals negative 1.
X equals negative 1. Why is x equals negative 1 a vertical asymptote?
Because it makes the
Denominator
denominator.
blow up.
Yeah.
It makes the denominator 0. So we're going to have a similar situation here where we're going to approach from left and right. So I'm going to have a situation here where I am going to go like this, and then on this side it's going to come down from infinity as well. And then, so that's the horizontal asymptote, or sorry, that's the vertical. Is x equals minus 1. I don't know if you can guess, but as x approaches infinity,
What does that say? Vert-asump?
vertical asymptote. It's the vertisump. So we're gonna, this is a little bit of a preview of like pre-calc notation, but in the limit as x approaches infinity, 2x plus 1 over x plus 1. Any guesses? So we have a very, very large number in the numerator multiplied by 2. So like 10 quintillion, like f of 10 quintillion is what? Approximately.
I can tell you.
So if I put, what is f of 1?
Three halves.
3/2. What is f of 10?
So you just plug in what? Whatever number?
21 over 11.
You're just plugging in random numbers on?
I'm plugging in increasingly larger numbers.
21 over
21 over 11, f of 100,000.
It's gonna be like small. It's gonna be small.
Is it small?
Small.
No, 200,001 over 100,001.
Which is approximately,
Oh snap!
approximately what?
2.
2. F over
quintillion is, it's 2.
2 quintillion.
It's
Right.
closer to
10
2.
quintillion is approximately 2. It's very close to 2. So in my limit, as x approaches infinity, 2x over 1 over x plus 1, 2x plus 1 over x plus 1, it equals what? This is my way of saying let x get super, super big. X is approaching infinity. I think you already have the answer.
What is the answer? I'm confused.
So we're looking at increasingly larger numbers
But like.
and
is
seeing
there-
that they're getting closer and closer to 2. Using this limit notation, I can just go ahead and say it's 2.
So you're just supposed to like go up by like billions?
Well, I'm noticing a pattern because if I say x is 50 million, then it's going to be twice 50 million approximately over 50 million approximately. And as the numbers get bigger, this plus 1 matters less and less.
I see.
So so we actually can write this as a limit and say, well, this is essentially multiplying the number by 2 and dividing it by the same number. That's just 2 over 1. So where do you think our horizontal asymptote is? Yeah. This is poorly drawn. It's more like this.
That's really
What's that? So my horizontal asymptote is, what's the equation of this line? Eric?
This line,
The horizontal dotted line?
y equal 2.
Y equals 2. Great job.
Mr. Shadle, could you go up a bit more? Yeah, that's fine, yeah.
Okay, I'm going to draw another function. This is the graph of f of x equals 4 over x squared plus 1. And what is f of 0?
0. Oh,
Uh,
undefined.
No, it's not. No, it's not undefined.
Oh wait, it's 1. 4 over 1.
It's 4 over 1, so it's 4. 1, 2, 3, 4. Passes through 4, 0. My y-intercept is 4. And then it just smooths out. More like this.
Why does it do the weird dippy? Like the.
Hey, no
empty
phones!
Dippy.
Put it on my desk.
What was the faculty's like thing today? Like, it's like white shirt, vest.
Yeah, white shirt, vest, and blue jeans.
Yep.
No, because Mr. Bloom was wearing jeans.
Well, that's on Mr. Blair.
So, can we think about what happens to the value of f of x when x approaches infinity?
The value of x gets.
F of x.
Oh. It gets closer to. I don't know. 4.
What is 4 divided by 50 quintillion squared plus 1?
0.
Yeah. So what's our horizontal asymptote?
0.
What's the equation of the
Oh, y equals 0.
that's our horizontal asymptote. That's our horiz asymptote.
Why does it do the weird Humpty Doodah?
Because as x is approaching 0, we're getting closer to just having 1 in the denominator, and so it sort of does a bell curve up. I don't know how good my drawing was, but you can check it in Desmos.
Okay.
Okay, so I'm going to graph f of x equals 2 over x minus 1 squared. And where are we expecting a vertical asymptote?
0.
X equals 0 is absolutely no problem.
Oh, oh, oh. 1.
A vertical or horizontal?
Vertical, vert.
2, never mind.
2.
2, yeah.
Since that one happened at 4, right?
Well,
A horizontal asymptote is what happens as x approaches infinity.
wait, horizontal.
Horizontal. Vertical asymptote happens when the denominator blows up. Annabelle, help us out.
Well, if you have 2x minus 1 squared, then you have to do the, what's it called, the x to, like, if x equals, what's it called? If x, so x goes all the way to infinity.
No. I want to look, right now I want to look for vertical asymptotes. Charlotte?
Would it be like 1 and negative 1? Because, like, wouldn't both, wait, this is new.
So f, let's double check. F of 1 is what? 2 over 1 minus 1 squared is, simplify that?
0.
Yeah, 0 squared,
Undefined.
or 2 over 0, and that's undefined. Okay, let's check f of minus 1. Warren, help me figure out what f of minus 1.
That's minus 2 squared, so 4. So over 4.
Step by step.
Okay, so you input minus 1 for x.
Mm-hmm.
You get minus 2.
Step by step. I started very methodically on this one. That's what I want to do.
2 over
Mm-hmm.
parentheses minus 1 parentheses squared.
Mm-hmm.
That's 2 over minus 2 squared. That's 2 over 4.
So no vertical asymptote at minus 1.
For the one,
It's no problem.
for the last one, would it have been negative 1 and, wait, how do you get a parabola?
It's not a parabola.
But how would a parabola happen?
Y equals x squared.
Okay, never mind.
Yeah. No. Are there any vertical asymptotes for y equals x squared?
No.
Oh, yeah, it's the origin. It's the. Isn't it
The origin?
Or, no, that's the axis of symmetry, never mind.
Right. Okay, so where are we? So now we figured out where the denominator is going to explode. Where are we expecting our vertical asymptote?
1.
1
Like this, vertical.
half.
What's the equation for that?
X equals 1.
X equals 1, and that's our vert asymptote. And then the rest of the equation looks like this. So, based on that drawing, where is our horizontal asymptote? It's kind of the same. It's very similar behavior here. I have a denominator that grows as x approaches infinity, and I have a denominator here that grows as x approaches infinity. So it's, as the denominator gets huge, the f of x approaches 0. So what's the let's see, Sydney, what's the equation of this horizontal line?
0. Y
That's
equals
not
0.
y equals 0 is my horizontal asymptote. Okay, let's look at we've sort of figured it out on a case-by-case basis, but let me give you some rules to make it easier to find out vertical and horizontal asymptotes for any rational function. Kira.
What do like your asymptotes actually like mean? Like what are they? Or like what do they do?
That is the equation of a line that as x approaches infinity, f of x gets ever closer to it without reaching it.
Okay. So it kind of just like they exist.
It's like a boundary.
Okay.
So this vertical line, you can never reach it because it would explode the denominator.
Yeah.
But as x approaches 1,
Then you're
from either side,
0.
the f of x approaches infinity in this case.
Okay.
Yeah, it's a boundary. It's a line that the function gets ever closer to without reaching it. So let's look at some rules to be able to figure out what's going on in general. So,
Mr. Shadle, when's your birthday?
so I'm gonna call my rational function, my polynomial, in the numerator as capital N, and my polynomial in the denominator as capital D, and then here at the end I'm gonna say where N and D have no common factors.
Does that say vertical?
Mr. Shadle,
Hmm.
do we have class tomorrow? Can we work on our lab today?
Wait, is our lab due tomorrow?
Like, the lab due on Friday, so that's the next class. And so usually like the class before.
So what's my general? How do I write a polynomial in general?
Yeah, but now he's like,
How? Amelia, I would like to have class, please. How do I write what's the general notation for a polynomial? What's a polynomial? What's an example of a polynomial function?
F of x equals 2x plus 7.
Okay. Or
Yeah, that's it.
so in general notation, instead of choosing 1 or 12,
ax squared plus bx plus c.
ax not squared.
To the n.
Yeah, and this would be coefficient number n.
X.
Yeah, x to the n plus,
This will be x to the n.
and I'm gonna decrease
This is, yeah.
dot 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 all the way down to ax1 times x, and that's an implied 1, plus ax0. This is my general notation. I don't know how many I need. So if I have a polynomial of order 12, then I'm going to have an x to the 12 and an x to the 11, possibly with a non-zero coefficient. I don't know, maybe it is 0, all the way down. So I'm going to have, this will be my coefficient number 12, this will be my coefficient number 11, this will be my coefficient number 9, let's say, in this example. So I'm just saying I have n coefficients, n number of coefficients. I'm just saying this is a polynomial, and I don't know how many terms that it has. So I'm writing it in general notation. So in the bottom, instead of using a, I'm going to say I can't really say a to the n because that means they have to be the same.
Oh, a to the m.
Not even a.
B to the m.
B, I'm sorry, not to the, but sub
Oh,
m
sub m
times x
to the m.
to the m,
I'm so confused. What are we doing?
writing in general notation. We've done this before.
Well, why are we doing it now?
because I'm giving you a definition, or I'm giving you some rules in terms of a polynomial in the numerator, polynomial in the denominator. That's what a rational function is.
Is it a point x?
A where?
A1 x.
No, on like the end of your notation at top.
A sub 1 times x,
And then a o.
a sub 0. And then the b's start with number m, and then the next one down, and then all the way down to 1, and then all the way down to 0. And f is a function of x. That's why there's an x in the numerator and denominator. So here's some rules. Rule number 1 is the graph of f has vertical asymptotes at the zeros of d of x. Why do we say that based on our examples that we've looked at? Why vertical asymptotes at the zeros of d of x?
Because as the denominator approaches its like limit, that is where
As it approaches 0.
0, yeah.
So the zeros sort of recognizes that there might be more than one reason, more than one place where the denominator might equal 0, but anywhere that my whole rational function, the denominator equals 0, that's going to explode my equation. It's going to blow it up, and I'm going to have a vertical asymptote. So anywhere where the denominator is 0. And writing it this way, at the zeros of d of x, recognizes that there might be more than one place where the denominator would be 0. So I think we understand that rule. Rule 2. So we might have a horizontal asymptote, might have one, or maybe not. Horizontal asymptotes by comparing the degrees of n in this way. So case number 1, n is less than m, so the degree of n is less than m. So what is the degree of the numerator?
N.
Right. What does that mean? How would that look in an example?
Numerator is smaller
Like-
than the denominator.
Not that the numerator, not the value of the numerator,
The power.
the degree.
Oh, okay.
The degree. So n, the largest exponent of n, if the degree is larger on the bottom, that's n is less than m. If that happens, the graph of f has the line y equals 0 So if the degree is smaller on the top than it is on the bottom, that means the bottom grows larger than, faster than the top grows. So that means eventually it goes to 0. So it's not just that it has a horizontal asymptote, it actually has an horizontal asymptote at y equals 0, the x-axis, when n is smaller than m. What's another case?
When n is bigger than m.
So we can look at when n is larger than m, and then what's my third case going to be?
They're equal.
When n equals m. So we've got 3 possibilities for the degree. Each the numerator and the denominator are both going to have a degree. Sometimes the numerator is going to be smaller, case A. Sometimes the denominator is going to be smaller, and sometimes they're going to be equal. So I have 3 cases for that. So when n is greater than m, the graph of f has no horizontal asymptote. Okay, last case. This is the only one that's a little bit complicated. This is easy. We might have a horizontal asymptote at the x-axis. In this case, we have no horizontal asymptote. This last case, when n equals m, they're the same degree. Then we have to do a little bit of figuring. So let's write out what that rule is. What does that mean?
The number with the highest power in the numerator and the number with the highest power in the denominator.
No. What's another name for a sub n and b sub m? What do we call this?
Oh, the coefficient.
What is
of
it? Yes, that's almost there.
The leading coefficient.
Leading coefficient. It's the ratio of the leading coefficients. So so what does this mean? How can I get my horizontal asymptote from this one neat trick? How would that come up? Sydney?
How would it come up?
Yeah. Like what kind of rational function would you have? Like what would be a scenario where you could use this y equals an over bm?
Yeah, I have no idea.
What's the case? What's the setup?
When n equals m,
Yeah, what does that mean?
that they're equivalent.
Like f
And remind me what is equivalent there?
They're the same number.
What are?
M and x.
M
F of whatever is equal to
no.
m.
No. Nope. No. Explain it to me, Warren.
I'm confused.
So what does this case mean? When would case C come up?
Like when the exponents are equal.
The exponents are equal? What does that mean? That's not the way I would describe it. Can you be more specific, Carlo?
No, I can't. When no, I couldn't tell you.
Charlotte, can you explain it to us? Annabelle, why is your laptop open?
It's
Close your laptop. Oh, you did.
It's when like ax, an to the power of xn plus an minus 1, that equation,
Mm-hmm.
when the exponent n and m, or not the exponent, but they're
Can you make
both-
up an example?
like give you the equation, or
Yes.
make up like something?
Give me make up an equation where you're going to
Okay.
use this, and then give me the horizontal asymptote.
F of x equals a.
No. Give me a real example. 2 or 10 or
Oh.
a real example.
7.
Okay, equals 7.
And, yeah.
Mm-hmm. Keep going.
That's equal to the 7 n of x, and then over d of x.
Yeah, I need an n of x
Yeah.
in the numerator. So you're give me a
I give you just
give me a
numerator.
polynomial, for example. Make up one.
10 over 5.
No. You start with a polynomial. It's going to be 7x to the something.
Oh, so 7 is the n.
7 is the a.
I think I'm confused.
What is n? What is m?
N is the numerator.
It's not the numerator. It's look at this is little n. Little n means this. This one.
Yeah, but it's all in the numerator, and all the n's are on the denominator.
All the n's are in the numerator, but what is n? This is n. All the rest of them are n minus 1, or n minus 2, or n minus whatever, all the way down to 1. The biggest one is only that's the only one that's n.
Degree.
It's the degree. The degree. So what does this case C n equals m mean?
The degrees are equal.
The degrees are equal. So give me a polynomial, or give me a rational function. That's a polynomial in the numerator and a polynomial in the denominator, for example, that we can use for case C. Go ahead, Kira.
3x squared plus 2x plus 11 over 7x squared plus 9x plus 3.
So 3 is a. No, I'm confused.
So yeah, an equals 3 and then bm equals 7. But like
Okay, yeah.
n is 2 in that case because they're both squared.
You agree with all the stuff that I've written? The leading coefficient here is 3. The leading coefficient here is 7. The degree of the numerator is 2. The degree of the denominator is 2. So n equals m. So we want to use case C. So what is so the graph does have a horizontal asymptote, and where is it?
3 over 7.
Y equals a sub n over b sub m. That's 3 over 7. That's my horizontal asymptote. And you can imagine why that would be, because if I have f of 5 quintillion, I have 3 times 5 quintillion squared. That's going to be the dominating number in the numerator, divided by 7 times 5 quintillion squared. That's going to be the dominating number in the denominator. And I'm going to have similar numbers, and this levels out at that ratio when the degree is the same. So I end up with a horizontal asymptote at 3/7. Great job.
What if I had said like 6x squared? Like, you know, at the beginning you said that n of x and d of x have no common factors. If like
No common factors. Right. That means there's no reducing to go on.
oh
So these things don't really apply until you have a reduced rational function. So if n and d, yeah. So if you have something that could be factored into x plus 1 times something else
then you have
over
to
x
first,
plus 1 times something else,
like, you
then
should simplify.
we should simplify first, and then once we're finished simplifying, then we can use these 2 rules and these 3 sub rules within rule 2. Annabelle.
So here is like an asymptote, right? you have, it starts at where y equals, right?
So horizontal asymptote is always going to be y equals
Yeah.
because that's what am I trying to say? An equation for a horizontal line is always, it gives you the y value. It's always y equals something.
Okay.
The formula for a vertical line, that's always a set value for x, so it's x equals some number, some constant.
Oh.
A vertical line always has x equals something.
When
A
you were
horizontal
explaining,
line is always y equals something.
When you're explaining it, I thought y equals like x equals a specific number, whereas y could be anything.
This is the equation for a line. So this is why anything along this line is always going to have y as a value. So it could be -1, and then it's b, and then it's 0, and it's b, and then it's 1, and then it's b, and then it's 13, and then it's b. B is redundantly, I mean, this is predictably, it's
like
always
K.
b.
It's like K, it's always
It's a constant.
B
It's
is
a
always
constant. That's what makes it a horizontal line.
Okay.
Here, the x is always constant, so that's what makes it a vertical line.
Okay. And then when you have your numbers and you plug them in, that's when you can find your what's it called? Your asymptotes and all that stuff,
Yeah.
right?
Right. So for finding vertical asymptotes, this is the only rule you need. Any zeros of the denominator, that's going to give you your vertical asymptotes if you have any. If D has any zeros. For horizontal asymptotes, then you have this list of things. So let's do some examples. All right. So using your powers of having the rules in hand, please find the horizontal and vertical asymptotes of f of x equals 2x over 3x squared plus 1. Look at rule 1, look at rule 2, and then figure out if you need to use A, B, or C.
Wait, what are rule 1? What's rule 2?
This stuff.
Oh, okay.
And when you get done with that, do this one. Warren, are you writing furiously?
I'm pondering.
So you should have your list of rules in front of you, and then you should start applying the lists to A,
So
function A and function B. What color?
never mind.
Does everything have to have a vertical asymptote?
So does every function have, does every function cross the x-axis? No. If it doesn't cross the x-axis,
Then it doesn't.
so if D never causes your rational function to blow up, then there's going to be no vertical asymptotes.
Okay. Okay.
So it's only when the denominator is 0. So that's why we say the zeros, because it could be plural, of the denominator.
Okay.
That's all that. If it has one or more, that's your vertical asymptotes. If it has
that's
none,
An option.
then you have no vertical asymptotes.
Got it. Thank you.
Michelle, I'm so glad we didn't have our test today because I have my chem test today.
Our chem test is actually rough.
I talked you into it.
I've
It's
talked
so
to like,
rough.
no it ain't. I've talked to like
You
5
didn't
people.
take
Who'd you
Yeah.
talk to?
I've-
Who'd you talk to?
Did I talk to him?
If it's
I talked to
hard-
August Vidmore.
I would like to find out if you can do this, please. Work on A at least.
Oh, no.
If you get done with A, work on B.
No, Annabelle, you're stressing me out now.
There's stuff on it.
Amelia and Annabelle, work on A and B.
Sorry. And I'm stressed because I'm really bad at chem.
Amelia,
Sorry. I had to FaceTime Molly for
Amelia.
I'm sorry. Never mind. Wait, why do they always get out like 10 minutes before us?
Yeah, they're so lucky.
So you can leave after you find the vertical and horizontal asymptotes for A.
Oh, we already did that.
Is there
I
no
did that
vertical
too.
asymptote of A?
Oh, you're honest.
Does 3x squared plus 1 have any real solutions?
No.
Or 3x squared plus 1 equals 0, does it have any real solutions? No, it doesn't have any real solutions.
So there's
Did
no.
we
So
teach you
no
that thing where
vertical
it's like,
asymptotes.
where if it's like on the bottom, so if the bottom is 0, then it's NO, but then
Yes.
if the top
Yes,
is
it's
0, then it's
okay.
OK.
Yes, you taught me that and you taught me
No,
copy dot
no.
flip.
The horizontal is y equals 0.
Horizontal and y equals 0.
Yeah.
Alright, I'm done. For the first one.
What did you get?
Wait.
Here's what it looks like.
Is the vertical?
It's not.
Oh.
It's like undefined. Yeah, undefined.
Oh, let's see.
There's no vertical. There's only horizontal.
Can we put undefined?
And it's y equals 0.
I put undefined or none.
So none.
None. Not
So
undefined.
no
Can you-
vertical asymptote. So
Can you say undefined too?
so vert, it's not undefined.
Oh,
It
so
doesn't
if I put
exist.
Undefined on the thing, then that's
So
wrong.
vertical asymptote is none. Horizontal.
It's not.
Oh, I said vert.
Horizontal is y
Vert
equals
horiz.
0.
That's not what I meant. So vert asymp is none. Horiz absent
Is 0. Like.
is y equals 0.
I have it for the
Super
second one.
boom, super shakalaka.
Super
Can I do the
good.
second one?
Huh?
For everything.
Yeah, do the next one.
Can I check my answers?
Go ahead.
The vertical asymptote is 1, and then the horizontal asymptote is 2.
Not quite.
Oh.
There's two places where the denominator has zeros.
It's 1 and negative 1.
So this actually looks like this.
That's what I was going on about.
Yeah, because it's just an
It looks like this, and this, and this.
Oh, so that's where you get your parabola.
Yeah, that's the parabola.
Bet.
That's weird.
That's what I was
But
talking
I
about.
get
Okay, y'all can go 25 seconds early.
Hey, thank you.
Wow.
Appreciate that.
I did say
My
something
perfect
about
pen.
Thank you, Mr. Sim.
Have a good day.
I
Are
have
we
a question.
still have more
I have a
4.1
question
notes?
before I leave.
I just realized
Like a
I'm
lot.
Yeah, bro.
Yeah,
Yeah.
bro.
Yeah.
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 Are you what?
Yeah, bro.
Is it possible?
I would say one more day. I would say one more day.
Yeah, no, you
One more
can
day.
put my jacket.
2.5 pages of notes today.
Is it possible for you to share with me like the recording of today's class? So like I can like go over the notes one more time?